Welcome dear children. In today's session we are going to learn Standard 8 Science subject, in that Unit 13 Water. நீரென்று அமையாது உலகினின் யார் யாருக்கும் வானின்று அமையாது ஒழுக்கு. Children, Tirukural says without water there would be no life on the earth. Just like other living organisms, we also need water to survive. Children, we need water for so many activities like cooking, washing, cleaning and irrigation. Water is an inorganic. Why it is an inorganic? Because no carbon will be present in water and it is transparent, tasteless, odorless and nearly colorless chemical substance which is the main constituent of Earth's hydrosphere and the fluids of all known living organisms. Water is vital for all known forms of life, even though it provides no calories or organic nutrients. Its chemical formula is H2O, meaning that each of its molecules contains one oxygen and two hydrogen atoms connected by covalent bonds. Covalent bonds are chemical bonds present between two non-metal atoms. Children, water is one of the basic needs and is required by all life on earth. It dominates a majority of the space on our planet, covering about 71% of the total surface area of earth. Hydrology is the study of the distribution, availability, consumption and movement of groundwater. Children, water exists in all three of its states, namely solid, liquid and gas. It is a transparent, colorless chemical substance with one oxygen atom covalently bonded to two hydrogen atoms, we know that. Water is cycled continuously on earth through evaporation, transpiration, condensation, precipitation and by other means. Water consumption and use is defined as the water that is drawn continuously from surface or ground and that is utilized in such a way that it is no longer available for further use. Children, water resources are getting depleted nowadays because of growing demand from increasing populations and lifestyle changes. There is also a reduction in the supply of water due to pollution of water sources and climate change, which contributes to the rising variability in rainfall. So children, we all depend on water for our living and so every individual is responsible for saving water. In this lesson, we will learn about the sources, properties of water. Next is the composition of water. Children, 3/4 of our planet Earth is filled with water. Water exists in three states. What are the three states? Solid, liquid and gas. So, water on the surface of the earth is found mainly in oceans as 97.25%, polar ice caps and glaciers as 2.05% and the remaining is in lakes, rivers and aquifers. Aquifers means groundwater. Even our body is made up of water. 65% of the water is present in our body, but it is not apparent. Water is a chemically stable compound. Its chemical name is dihydrogen monoxide, that is H2O. It can be broken up into hydrogen as H2 and oxygen as O2 when an electrical current is passed through it. The process of breaking down of water molecules by the passage of electric current is known as electrolysis of water. What is electrolysis, children? The term electrolysis was introduced by Michael Faraday in the 19th century. The word electrolysis is a combination of two terms, electron and lysis. Electron is related to electricity and lysis means decomposition. Next is the electrolysis of water. Children, electrolysis of water can be easily demonstrated with the help of an experiment. Listen, in this experimental setup, a glass beaker fixed with 2 carbon electrodes. It is filled with water up to 1/3 of its volume. The positive carbon electrode acts as anode and the negative carbon electrode acts as a cathode. What is meant by electrode, students? Listen, an electrode is an electrical conductor used to make contact with a non-metallic part of a circuit. For example, a semiconductor, an electrolyte or a vacuum or air. Next, the electrodes are connected to a battery and current is passed until the test tubes are filled with a particular gas. Listen, if the gas collected is tested using a burning splint, we can notice that the gas in cathode side burns with a popping sound when the extinguished splint is brought near the mouth of the test tube. This property is usually shown by hydrogen gas, and so it is confirmed that the gas inside the test tube is hydrogen. Next, the burning splint placed near the anode side burns more brightly, confirming that it is oxygen gas. So, this experiment shows that water is made up of hydrogen and oxygen. Next, the ratio of hydrogen and oxygen will be 2:1. Hence, for every 2 volumes of hydrogen collected at the cathode, there is 1 volume of oxygen collected at the anode. There is one chemical reaction for this preparation. Water, when it undergoes electrolysis, that is 2 molecules of water, when it undergoes electrolysis, 2 moles of hydrogen gas and 1 mole of oxygen gas will be produced. Next is the preparation of water. Children, water was first prepared in 1781 by an English scientist, Henry Cavendish. He discovered hydrogen gas when active metals reacts with sulfuric acid. The hydrogen gas released was highly inflammable and burned to form a colorless product called water. There is one chemical reaction for this preparation. Listen, when zinc is said to be an active metal, when it reacts with sulfuric acid, zinc sulfate and hydrogen gas will be produced. The next reaction, when 2 moles of hydrogen reacts with oxygen, 2 moles of water molecules will be produced. Children, water is also produced by the reduction of metal oxide by hydrogen, burning of hydrogen in air and burning of hydrocarbons in air. Respiration of plants and animals also releases water. For example, when glucose reacts with 6 moles of oxygen, 6 moles of carbon dioxide, 6 moles of water molecules and energy will be produced. Children, whenever you write any chemical equation, you should check whether the equation is in the balanced form. When we can say that the equation is in the balanced form? Listen, when the number of moles of the reactants is equal to the number of moles of the products, in that condition we can say that the equation is in the balanced form. Children, you should also know about Henry Cavendish. He was a British philosopher, scientist, chemist and physicist. Cavendish is noted for his discovery of hydrogen. He called it inflammable air. He mixed metals with strong acids and created hydrogen. He created carbon dioxide also by combining metals with strong bases. Next is the laboratory preparation of water. Children, water can also be prepared in the laboratory. Listen, it will be very interesting. The apparatus used for the preparation of water in the laboratories is given in the image. In this method, pure hydrogen gas is passed through anhydrous calcium chloride to absorb water vapor if present. Anhydrous calcium chloride. How anhydrous calcium chloride will be? It is a white or light grey granulose, purely hygroscopic odorless substance. It absorbs water vapor vigorously, forming solid hydrates. Children, dry hydrogen coming out of the opening is burnt with sufficient supply of air. The burnt hydrogen gas forms droplets of water when it comes in contact with the cold flask. Next, distilled water without any dissolved matter is obtained by this method. The water from which impurities as dissolved salts and colloidal particles have been removed by one or more process of distillation. That is, the distillation process will be repeated again until we get a chemically pure water. Next is the properties of water. Children, water has some important properties which are familiar to us, but these properties are unique to water. Some of the physical and chemical properties are given. First, let me explain about the physical properties of water. First is nature. How water will be present in nature? In nature, pure water is a clear and transparent liquid. It is colorless, odorless, and also it will be tasteless. Next is the boiling point. The boiling point of water is 100 degrees Celsius at 1 atmospheric pressure. At this temperature, water boils and changes into steam. The boiling point of water increases with increase in pressure. For example, when a pressure cooker is heated, a high pressure is built inside it. The high pressure increases the boiling point of water. Thus, water remains a liquid at a higher temperature even at greater than 100 degrees Celsius in the cooker. This cooks the food faster. Children, do you all know pure water has the following physical properties? Pure water boils at 100 degrees Celsius at 1 atmospheric pressure. Pure water freezes at exactly 0 degrees Celsius at 1 atmospheric pressure. Is it very interesting? Next is the freezing point. Water freezes at 0 degrees Celsius and forms ice. Thus, the freezing point of water will be 0 degrees Celsius. So, the freezing point of water decreases with increase in pressure. Next is the density. Children, when ice cubes are put in a glass of water at room temperature, they float on the surface of the water. This is because ice is lighter than water. It means the density of ice is lower than that of water. Children, do you know when the skaters move on ice, they exert pressure on it. This pressure lowers the freezing point. As a result, the ice melts underneath the skate and allows the skaters to glide across the ice with little effort. So, when the skaters move forward, pressure is decreased and the water refreezes to ice again. When the winter temperature is below 0 degrees Celsius, the water in the lake will start freezing. The frozen ice will float at the top and cover the lake. Since ice is a bad conductor of heat, it does not allow heat to pass through it. So, the water below the ice remains in liquid form where most of the aquatic life lives. This enables the aquatic animals and plants to survive even in extreme cold conditions. The density of water at different temperatures is given. If the temperature is at 0 degrees Celsius, the density of ice will be 0.91 gram per cubic centimeter. If the temperature is at 0 degrees Celsius, in case of water, the density will be 0.97 gram per cubic centimeter. In case of 4 degrees Celsius, the density will be 1 gram per cubic centimeter. If it is greater than 4 degrees Celsius, the density will be lesser than 1 gram per cubic centimeter. So, 1 cubic centimeter will be equal to 1 centimeter cube equal to 1 m. Next is the vapor pressure. The vapor pressure of a liquid is the pressure of the vapor produced by evaporation of a liquid or solid above the solid or liquid in a closed container. The hydrogen bonding between liquid water molecules explains why water has an unusually lower vapor pressure. Relatively few molecules of water are capable of escaping the surface of the liquid and enter the vapor phase. Evaporation is slow and thus the vapor exerts a low pressure in a closed container. Low vapor pressure is an important physical property of water, children, since lakes, oceans and other large bodies of water would all tend to evaporate much more quickly otherwise. Children, whereas vapor pressure is influenced by temperature. As the temperature increases, more molecules are released from the surface of the liquid. This increases movement above the liquid surface, increasing the pressure in the vapor stage. Next is the surface tension. Children, water has a surface tension. Surface tension means the attraction between molecules at the surface of a liquid because of its hydrogen bonding. Liquids that cannot hydrogen bond do not exhibit nearly as much surface tension. Surface tension can be seen by the curved meniscus that forms when water is in a thin column such as graduated cylinder or a burette. Next is the anomalous expansion of water. Anomalous means from deviating from what is usual, normal or expected. For the same mass of ice and of water, the volume of ice is more than that of water. It is an unusual property of water, isn't it, children? In the Himalayas, the temperature can go down even below 0 degrees Celsius. The water in the water pipes will freeze at this temperature to ice. If the pipes are not strong, they can crack, develop leaks or even burst. This is because freezing of water will cause an expansion in the volume. Next is the latent heat of fusion of ice. Latent heat is energy released or absorbed by a body or a thermodynamic system during a constant temperature process, usually a first order phase transition. Two examples of latent heat are the heat of freezing and the heat of vaporization. The heat of freezing is the amount of thermal energy given off as a liquid freezes, and the heat of vaporization is the amount of thermal energy that must be added to change a liquid to a gas. Children, take some ice cubes in a beaker and place a thermometer in it. Now heat the beaker. The thermometer will not register any rise in temperature till all the ice melts. The question arises, where does the heat energy go if there is no rise in temperature? The heat energy is utilized in changing the state of ice from solid to liquid. So, the amount of heat energy required by ice to change into water is called latent heat of fusion of ice. Ice has the highest latent heat of fusion, that is 80 calories per gram or 336 joule per gram. The formula of latent heat of water is heat added or subtracted for a phase change is equal to latent heat into mass. This Q equal to latent heat into mass, where Q is equal to heat. Its unit will be calories or joules. L refers to latent heat. Its unit will be calories per gram or joules per gram, whereas M, that is mass, will be expressed as grams. Children, do you all know the freshness of fish and meat can be maintained by placing them in contact with ice? With its larger latent heat, ice is able to absorb a large quantity of heat from the fish as it melts. Thus, food can be kept at a low temperature for an extended period of time. Next is the latent heat of vaporization of water. Children, when water attains the temperature of 100 degrees Celsius, it starts changing its state from liquid to gaseous state. However, the temperature of water does not rise above 100 degrees Celsius. That is very important. It is because the supplied heat energy only changes the state of the boiling water. This heat energy is stored in steam and is commonly called latent heat of vaporization of steam. Here the steam has the highest latent heat of vaporization and its value is 540 calories per gram or 2268 joules per gram. Next is the specific heat capacity. Children, the amount of heat that is needed to raise the temperature of a unit mass of a substance by 1 degree Celsius is called specific heat capacity of a substance. This is very important definition. So, the specific heat capacity of water will be very high. When 1 gram of water requires 1 calorie of heat to rise its temperature by 1 degree Celsius. So, due to its high specific heat capacity, water takes time to become hot as well as to cool down. Thus, water can absorb a lot of heat and retain it for a longer time. This property of water is used to cool engines. Water is circulated around a car engine using the radiator pump and the heat is absorbed. Thus, the engine is protected from getting too hot. Next is the chemical properties of water. First is amphoteric nature. This is one of the unique quality of water. An amphoteric substance is one which can act as an acid or a base. While water is neither acidic or basic, it acts as both. This is because of its ability to both donate and accept protons. Some of the examples for amphoteric nature of water are given. Listen, when water reacts with HCl, that is hydrochloric acid, hydronium ion and chloride ion will be formed. Next chemical property is the stability. Children, water is a very stable compound. It does not decompose into elements when heated to ordinary temperatures. They have given the reaction when 2 moles of water molecules undergoes reaction at 2000 degrees Celsius. 2 moles of hydrogen and oxygen will be produced. Next is the action towards litmus paper. Children, pure water is neutral and it shows no action towards litmus paper. Litmus paper is a tool used to test whether a substance is an acid or a base. Children, when a substance is dissolved in water, the resulting solution causes the litmus paper to change color. So, the acidity or alkalinity of a solution is determined by the concentration of hydrogen ions or power of hydrogen expressed as a pH value. So, a litmus test provides a quick result but cannot determine the level of acidity or alkalinity of a solution. Next is the catalytic nature. This is also very important property. Water acts as a catalyst in a number of reactions. What is the role of catalyst, children? The catalyst will enhance the speed of the reaction. Listen. Perfectly dry hydrogen and chlorine gases do not react in the presence of sunlight. However, in the presence of traces of water, the reaction takes place with explosion to produce hydrogen chloride. They have given the chemical reaction when hydrogen reacts with chlorine in presence of sunlight, hydrochloric acid will be produced. Next chemical property is the reaction with metals. Children, water reacts with some of the metals. Metals such as sodium, potassium and calcium react vigorously with water at room temperature. Sodium reacts with water to form hydrogen gas and sodium hydroxide solution. Due to the heat evolved in this reaction, the hydrogen gas catches fire and also burns. The chemical reaction for this process is when 2 moles of sodium reacts with 2 moles of water molecules. 2 moles of sodium hydroxide and hydrogen gas will be produced. Next is the reaction of potassium metal with water. Potassium metal forms potassium hydroxide and liberates hydrogen gas along with lot of heat when it reacts with water. The chemical equation for this process is when potassium, that is K, when reacts with 1 mole of H2O, KOH potassium hydroxide and hydrogen gas will be produced. Next is the reaction of calcium metal with water. Calcium forms calcium hydroxide along with hydrogen gas and heat when it reacts with water. Next is the reaction of magnesium metal with water. Children, when magnesium metal reacts with water slowly, forms magnesium hydroxide and hydrogen gas. When steam is passed over magnesium metal, magnesium oxide and hydrogen gas are formed. Children, magnesium will be little more sluggish. Sluggish means inactive. So, it reacts with hot water and gives hydrogen and magnesium hydroxide solution. There is one chemical reaction for this. When magnesium reacts with 2 moles of water, magnesium hydroxide and hydrogen gas will be produced. Similarly, many other metals also react with water to form oxides and hydroxides. Iron is one such metal which forms iron oxide, commonly called as rust. Children, iron is used in many buildings, factories, bridges, ships and vehicles. So, the slow and gradual rusting of iron is called corrosion. Children, do you all know copper does not react with water at any temperature. That is why it is used for making pipes and boilers. The last chemical property is the reaction with nonmetals. Red hot carbon, called as coke, reacts with steam, steam means water, to produce water gas. Carbon monoxide and hydrogen gas, this combination is said to be a water gas. This water gas can also be called as syngas. So, when carbon reacts with water at 1000 degrees Celsius, carbon monoxide and hydrogen gas will be produced. Next, chlorine gas dissolves in water and produces hydrochloric acid. So, when 2 moles of chlorine reacts with 2 moles of water in presence of sunlight, 4 moles of hydrochloric acid and oxygen gas will be produced. So, my dear children, in this session we studied about the introduction of water, composition of water, electrolysis of water, preparation of water based on laboratory method and some of the physical and chemical properties of water. I hope you all would have understood. Thank you.